Hi, sir. I'm Louis Han. These are my group mates, Desmond Chong Yong Hong, Yong Chia Wei, and Li Jialong. We are from Group A, Smart Energy Management System. So, I would like to start the presentation first. The problem statement of our project is the amount of electrical energy generated by renewable energy sources is unstable and difficult to predict compared to non-renewable energy sources. Although there has fossil fuel power stations that can fill in the gap between energy demand and supply from renewable energy sources, lack of integration between various energy sources lead to poor efficiency in energy generation and allocation. Besides, operator cannot monitor and make adjustments to the resource to optimize the performance of energy generation and distribution. Last, the generation of energy is based on the gas of demand and cannot handle the demand flexibly. The objective of our project is to develop a system that aims to improve the efficiency of energy generation and allocation. In this project, the Amazon Web Services AWS platform is used to propose and develop a system called Smart Energy Management System (SEMS). The system aims to improve the efficiency of energy generation and allocation. Also, the system helps in monitoring the energy generated by different energy sources like solar, wind, wave, and fossil fuel. These are my presentation. I would like to pass the rest to my groupmate. Thank you.
Thanks, Weihan. This shows the architecture diagram of an Amazon Web Service-based smart energy management system. The system will be connected via Internet to three different sites, which is device, power grid, and energy source. The system user will use a device connected to the SEMS to monitor the energy produced. The power grid is connected with the system in order to pass energy consumption data to the system. The system is also connected with the energy source that allows the passing and receiving of energy generated data. Several types of AWS service is used. First, to increase the security part of authentication of user, AWS Contributor will be used to perform user authentication. This provides a simple and secure user sign-in, sign-up, and access control. Next, two AWS Lambda will be implemented. The first AWS Lambda will be used to receive the IoT data passed from IoT Core and pass the IoT data to API gateway, while the second AWS Lambda will be used to store the prediction made by AWS SageMaker and pass control energy data to AWS IoT Core. Next, API gateway will be implemented to store the IoT data passed by the Internet from the device size and AWS Lambda. Then, the Amazon S3 will store IoT data passed from AWS IoT Analytics. After that, AWS IoT Analytics is responsible to storing IoT data in AWS S3 and performing machine learning on data with AWS SageMaker. Next, AWS IoT Core is used to handle several tasks like passing IoT data to AWS Lambda, performing analysis during AWS IoT Analytics, storing the control energy data passed by AWS Lambda, and energy consumption data from the power grid side. And last, Amazon SageMaker allows AWS IoT Analytics to perform machine learning on data and pass the prediction to the AWS Lambda. That's all for my part. I will pass the presentation to the next member. Thank you.
Hi, I'm Desmond Chong Hong. Now I will demo our system. First is Amazon Connector. Here, the user pool that we create under app integration. Here we can find the app client. So here we can view the hosted UI. So this is the sign page. User can sign out by providing their username email and password. So I already signed out, so now I will show the sign in. So first user need to type in the username, then type in their password. So after sign in, this is the example page show. So now I will talk about the Aws Lt Core. So here we have created the LT thing. We have electric meter, battery, fossil fuel, wind turbine, and solar panel. So for the demo purpose, we assume this PC as our LT device. So we can use this code to publish and subscribe to a topic. So now I will first subscribe to a topic first. So we'll connect to the endpoint. Then here I will try to publish data to the topic. So now connecting to the endpoint. Now the message is published. So here we can see that the message is receiving. Next is the AWS IoT Analytics. So we have created the channel, the pipeline, data store, and the dataset. So after we publish the data, so here the channel will receive it. So here we can see the date and time we have already received the message. Then here the message is also stored in the data store. Now in the dataset we can run it and view the dataset. So this is the dataset. Next, I will talk about the AWS S3. So this dataset will then store to the S3. So here is the Amazon S3. The bucket is this. Then the data is stored in the LT dataset folder, this folder. Then here we can see that this is the data that we published just now. So this is the so here we can download if we want. Okay, that's all from me. Thank you.
Hi, my name is Cherry, and I will show the demo of SiMaker first. First, we type the SiMaker, and then we will go to SiMaker, and then we click the notebook instances. After that, create notebook instances. So until here, we just need to enter the instance name, and we output default, and the network put default, and then we click create notebook instance, and we will navigate back to the previous page, and we wait about 15 seconds, and it will show from pending to in service. After the in service is output, we click the open Jupyter, and we will go to here, and we just need to upload the code. And after upload the code, and we just click on the code, and then this and then this will be all of the code that's used to
learn and train the model. So I now will show the lambda. I now will show the IoT core pass data to lambda. First of all, we will put the IoT core as a trigger. After the loop is triggered, and then it should come to this lambda. So we click on this IoT core, and then so we just waiting, and then we just if we want to send message to lambda function, then we click add action and send a message to lambda function and click configure action. After that, we will back to that page, and it will come to show at here. So we now, because the loop if has already set up at here, this is the rules that we already set up. So it will select all the data from IoT data. So we now will test the data pass from IoT core to lambda. So we click this because just now we have put the command is select all from here, and we subscribe. After subscribe, the message we put this. The message we put this, and this we change to one of the energy, which is solar, and then we publish. Okay, so we now go back to the CloudWatch to view it, see whether it got passed the data to it or not. So this is the time. So we will see, and then we will see the data is passing from article to here, and so it means that it is successfully. So we now go back to the lambda, and this is API gateway, which is connect to the lambda already, and this is the link. So we just copy this link and then put it here, and then this is get method. Make sure that this is get method, and we click sending, and it will shows the output of the event. That's all for my part. Thank you.